Good morning everybody. Today we discuss about Cauchy's theorems on some problems on Cauchy's theorems on limits. Before going to some problems, let me know about two theorems on Cauchy's theorem on limits. There is no proof, only statement. I will give the statement. Please note down that statements. If sequence AN converges to N, then the sequence xn where xn is equal to a1 plus a2 plus a3 up to an divided by n also converges to n. That is, limit n tends to infinity an is equal to n, which implies that limit n tends to infinity a1 plus a2 up to an divided by n is also converges to n. All the sum of the terms of a1 plus a2 up to n is also converges to a finite limit. That is nth term, the sequence nth term is converges to limit n finite limit, and also all the terms also converges to finite limit. Second, theorem 2. If sequence an is a sequence of positive terms, then show that limit n tends to infinity an to the power of 1 by n is equal to limit n tends to infinity an plus 1 by an, provided, this should be important theorem, please remember this one, provided the limit of the RHS right hand side exceeds whether finite or infinite, whether finite or infinite. This if sequence A is the sequence of positive terms, then limit n tends to infinity an to the power of 1 by n is equal to limit n tends to infinity an plus 1 by an, provided the limit on the RHS exists whether finite or infinite. Please remember these two theorems, especially in the last theorem 2. Let us move on to the problems. The first problem, let's take a first problem. By using Cauchy's theorem on limits, by using Cauchy's theorem on limits, show that limit n tends to infinity 1 by root of n square plus 1 plus 1 by root of n square plus 2 up to 1 by root of n square plus 1n is equal to 1. So let's take an as nth term, let's take nth term an as n divided by root of n square plus n. So it can be written as root n into root n, that divided by, if you take root n as common factor, 1 plus 1 by n. Root n cancel. Therefore, limit n tends to infinity an is equal to limit n tends to infinity 1 by root of 1 plus 1 by n. As n tends to infinity, this becomes 0, that is 1. By Cauchy's first theorem, this is why we are considering an is equal to n by root of n plus n square by n. On simplification we get 1. So by Cauchy's theorem on limits, by Cauchy's first theorem, by Cauchy's first theorem on limits, we have limit n tends to infinity a1 plus a2 up to an divided by n is equal to 1. We already taken n as n divided by, we have taken an is equal to n divided by root of n square plus n. Therefore, limit n tends to infinity, so it implies that limit n tends to infinity an, so a 1 by n common, a1 is 1 divided by n is equal to 1 plus 1 plus a2 is n divided by, this is n common, n divided by root of n square plus 2 plus n divided by root of n square plus n is equal to 1. So it implies that limit n tends to infinity 1 by root of n square plus 1 plus, this is 1 by root of n square plus 2 plus dotted line 1 divided by root of n square plus n is equal to 1. This is the proof. By using Cauchy's theorem on limits, we can prove easily, that is the given problem is converges or converges to 1. So next, second problem. For second problem, show that the sequence n to the power of 1 by n converges to the limit 1. So an is equal to n, then take an is equal to n plus 1 by a is equal to n plus 1 by n, that is 1 plus 1 by n. So limit n tends to infinity an plus 1 by an is 1. So to show that n to the power of 1 by n is converges to the limit 1. Therefore, by Cauchy's second theorem on limits, by Cauchy's second theorem on limits, Cauchy's second theorem on limits, that limit n tends to infinity an to the power of 1 by n is equal to limit n tends to infinity an plus 1 by an. It implies that limit n tends to infinity an is n to the power of 1 by n as 1. Therefore, it implies that sequence n to the power of 1 by n is converges to 1. These are all about problems on Cauchy's theorem on limits. Thank you.